Yes, today we will discuss about substitution nucleophilic internal. Sn1 alcohol is treated with thionyl chloride. When the paired electron is subtracted by oxygen, it will get minus charge and the hydrogen will relieve as H plus. And in this case, thionyl chloride, the chlorine will takes the bond and get Cl minus charge, form a Cl minus, and these two will combine and form HCl and leave us HCl, and this negative attacks this positive side of the sulfur, so we are getting alkyl chlorosulfite. Here it is an intermediate, that is intermediate ion pair. See the alkyl bearing the positive charge and the oxygen bearing the negative charge. When the cleave is taken place by the internal change, that is the halogen, which is act as the more nucleophilic, it will attack the carbocation and the minus charge will attack the sulfur, so we will get sulfur dioxide and alkyl halide. Okay, the another example is in the presence of pyridine, again with thionyl chloride, the hydrogen gets removed, and see here the hydrogen gets removed, phenyl group and this ester group, hydrogen and oxygen. When this hydrogen approaches this pyridine end of the pyridine, one pair of the pyridine, and this chlorine will also forms the negative charge, and due to the excess bond it will have plus charge. So this is the case, that is this hydrogen and chlorine attacks this lone pair present in the pyridine. And as in the case of Sn2 mechanism, the removal of sulfur dioxide is taken place and we are getting this product. Okay, from the book I will show Sn1 mechanism and see here the Sn1 mechanism from the book. See, Sn1 reaction, it is a two steps process, and first one is slow step and second one is fast step. And first step is the formation of carbocation intermediate to heterolytic fission, and in the case of second step, the nucleophile attack the carbocation. Okay, here again the reaction depends upon only the concentration of the reaction substrate, so it follows the first order kinetics. See here, tertiary butyl chloride, on predetermined step it will form tertiary butyl carbocation because of the heterolytic fission, and when it is treated with water we will get tertiary butyl alcohol. Okay, the Sn1 reaction, Sn1 reaction. It is a substitution nucleophilic internal, that is the oxygen attacks the sulfur, and by removal of this hydrogen and chlorine we will get ROS ClO. Okay, next the intimate ion pair formation is alkyl group carries positive charge and the oxygen carries negative charge. See here, the chlorine will approach the carbocation, and in order to satisfy the sulfur valency, the oxygen will bond with sulfur, and in the next step this will remove us sulfur dioxide and we are getting alkyl halide. And one more example is given. See here, in the presence of benzene, the tertiary amine is treated with thionyl chloride and we are getting the inversion configuration. The first one is complete retention of configuration. Here the chlorosulfide from alcohol and thionyl chloride forms pyridine hydrochloride, and the chlorine is an effective nucleophile, being as the electron deficient. It will attack electron rich center. Because of electron rich center, it will affect the nucleus part. So it acts as the effective nucleophile, and the displacement of chlorosulfide ester by chlorine taken place through the Sn2 mechanism, that is complete inversion of configuration is taken place, and this is similar to Sn2 reaction and called out as Dawson procedure. See here, we are the see here what we are getting: pH, OH, CO ester and hydrogen, and again this hydrogen will approach, that is this oxygen will approach the sulfur and chlorine will cleave, and we will get this hydrogen and this chlorine reacted with pyridine, and we are getting Cl minus N plus hydrogen, and this is the intermediate one, intimate ion. And on further, the removal of sulfur dioxide will take place, and with removal of HCl, this hydrogen and Cl. This hydrogen and Cl and sulfur dioxide, like that the formation of product will take place. Okay, thank you guys.